So the next topic in your module 1 is small signal operation and models for BJT. Okay, and these are the questions that have been asked for the university exam. Okay, so first question B part. For the circuit shown in question, derive the expression for voltage gain. So this is your circuit given. It is asked for 6 marks for June-July 2019. Then first question C part, for a BJT amplifier circuit, obtain the expression for a small signal collector current, transconductance and voltage gain, which is asked for 8 marks Jan-February 2021. Okay. So these are the two important questions which has been asked. So under the small signal operation and models of BJT, we are going to study 4 subdivisions. Okay, so you are going to find out the value for your collector current and transconductance, base current and input resistance at the base, the emitter current and the input resistance at the emitter, and the voltage gain. So these two questions have been asked from any one of these, right? In this, expression for voltage gain is asked. In the second question, voltage expression for collector current, transconductance and voltage gain is asked. So these are the important questions which has been asked. So what is meant by small signal operations or small signal analysis? Small signal approximation stands for the small signal. If the input is a very small signal which is given, then it comes under this category. Okay, so in short, the small signal operation can be defined as it is a nonlinear replacement circuit for linear large signal model that incorporates DC bias condition and allows for the evaluation when a small AC signal is applied. So when a small AC signal is applied, you are going to find out the different parameters, or this is called as your small signal operation and model. So when you apply a small AC signal, what is the alteration which is being done? That is what you are going to do the analysis from the small signal operation. First one is your the collector current and transconductance, second one base current and the input resistance, third one the emitter current and the input resistance, and last one is your voltage gain. Totally 4 derivations are there. So for that you are going to take the symbol diagram. This is your conceptual circuit to illustrate the operation of the transistor as an amplifier, right? So what is this configuration? Common emitter configuration, right? You have the arrow mark towards the side. So emitter will be grounded. You are giving an output resistor RC. So this is going to be a voltage VCE. Here you will be getting your voltage VBE, and here this is your small AC signal which you are giving. This is small VBE, and this is your capital VBE. Here in this analysis, capital letters signifies the DC value and small letters signifies the AC value, okay, or small signal value. So this is your collector current small I, this is capital C, this is I capital B, and this is I capital E. What is this? This is the total collector current, this is your total base current, and this is your total emitter current in the presence of your AC along with that of your DC signal. Okay, so you know that the basic working principle, right? If the transistor has to act as an amplifier, it has to work in the active region. That is, your base emitter should be forward biased. So here it is NPN, right? Here it is forward biased, and your collector base output is your collector base is reverse bias. Here it is N, here it is positive. So here it is reverse bias. Input side is forward biased and output side is reverse bias. Okay, so this is your first diagram, whereas the second diagram signifies that it is working only in your DC bias condition. DC bias, what you are going to do, you are eliminating the input signal. VBE, small VBE, that is nothing but your small signal is eliminated for DC analysis, right? Only you are using the DC supply. AC is being eliminated. This is the modified diagram. So your capital IC, capital IB and capital IE, it signifies the current under this DC condition, because you have to fix the operating point, right? Okay, so taking so here you have the important points. Base emitter is forward biased by your battery or your VBE, and your collector base is reverse biased by VCC. Okay, the input signal to be amplified is represented by your voltage source VBE, that is superimposed on VBE. It is talking about your first circuit. Okay, small VBE. Now, the relationship for DC current and voltages, the relationship between your basic DC current and voltages. Only by applying DC signal, what are your 4 basic equations? Your collector current IC is equal to IS into e power or exponential of VBE divided by VT. All capital letters signifies the DC values, and IE is equal to IC divided by alpha, IB is equal to IC divided by beta. What will be your output voltage? Output voltage, if you take this loop VCC, how will you write? Here it is plus, right? So plus VCC, here it is plus to minus. So take the second polarity, minus ICRC. Here it is plus to minus VCE, right? So take the second polarity, minus VCE is equal to 0. So what is going to be your VCE when you take it the other side? VCE is equal to VCC minus ICRC. So this is given as your last equation. Output voltage VC or VCE is equal to VCC minus ICRC. So these are the 4 different equations. Okay, diode equation, current equation. This you know that IC is equal to alpha into IE, IC is equal to beta into IB, and output voltage. Okay, these are the 4 basic equations which you are going to start with. Now when you apply your small AC signal, you are going to find out the first parameter, the collector current and the transconductance. So you are going to find out the collector current due to your AC signal. So it is small I suffix small c. That is your aim. Okay, small signal collector current. So for that you have to begin with, if a small VBE is applied, the total instantaneous base emitter voltage VBE becomes. Now what will be your total V, small v, capital B? Total voltage is given by VBE is equal to the DC plus your AC VBE, right? So VBE plus small VBE. So this stands for DC and this stands for your small AC signal VBE. Therefore the collector current becomes, what will be your collector current? IC will be equal to the total collector current I small I capital C. So this is your collector current. IC will be equal to, what will be the value you will be getting? IS into e power VBE divided by VT. Now instead of VBE you are going to substitute the value, right? That is what done here. So which is equal to IS into e power capital VBE plus small VBE divided by VT. You can write e power division, you can split it and write, right? So IC is equal to IS into e power VBE divided by VT into e power VBE small VBE divided by VT. Now you know that by equation 1, what is your DC collector current? IC is equal to IS into e power VBE divided by VT, right? So the first term is, this is nothing but your DC current IC. So you are replacing your first term by IC. So using equation 1, you can write IC is equal to capital small I capital C is equal to capital IC, the DC current into this term, e power small VBE divided by VT. Let me take that as equation 5. Now your VBE is very less than your VT. What is your VT? VT is nothing but your thermal voltage. Okay, so this thermal voltage VT is equal to small kT divided by Q, where K will be your Boltzmann constant, T will be your absolute temperature, and Q will be your charge. Okay, magnitude of your electric charge. Okay, so your VBE is very less. So if I take VBE is very less than VT in equation 5, now this equation 5 can be approximated as IC is equal to capital IC into 1 plus small VBE divided by VT. How did you get this 1 plus small VBE divided by VT? So you know that e power x is equal to 1 plus x square divided by 2 factorial plus, this is your expansion, right? So when your x is very small, you can neglect your higher order terms and you can take only your first 2 terms. So e power x is equal to 1 plus x. So in this case, x is equal to VBE divided by VT. So what will be the value? That's why it is written as IC into 1 plus small VBE divided by VT. That is taken as equation 6. So the reason is written here. Here the exponential in equation 5 is expanded in a series and only the first 2 terms are retained. This approximation is called as small signal approximation. So this is always valid for VBE less than 5 millivolt or 10 millivolt. So your small signal means the small signal will be very less. So what is your approximation taken? The VBE input sinusoidal signal will be less than 5 millivolt or 10 millivolt, then we can tell it as a small signal analysis. Okay, so under this approximation, now what is your aim? You have to find out your collector current, right? So when you cross multiply it inside, this IC can be written as IC plus IC into VB divided by VT. That is what given in equation 6. Okay, so what will be your total current? IC will be, this will be your DC and this is going to be your AC current, right? AC collector current. So this AC collector current, now I am taking it as small I small c. That is what written here. Okay, thus the collector current is composed of DC bias value IC and a signal component, that is small IC. This is also small IC. Okay, so this I am approximating it as small IC. This is nothing but your small signal collector current. So small IC is equal to IC into VT into IC divided by VT into VBE. This equation relates the signal current in the collector to the corresponding base emitter signal voltage. It can be rewritten as, so this is going to be your equation. Now this can be rewritten as IC by VT can be given by a term that is called as GM. This GM is called as your transconductance. Okay, I by V. Okay, so it is reciprocal of your resistance, transconductance, and from equation 8 it is given as GM is equal to IC divided by VT. So now for the first parameter we have found out both the value. IC will be equal to small signal IC will be equal to GM into VBE or IC by VT into VBE, right? And GM is equal to IC divided by VT. So we have got the first equation, first two equation. Now your second equation is what? Second parameter is you are going to find out the base current and the input resistance of the base. So now moving on to the second expression, that is so before going on to the second expression, if we give, so if you see the graphical representation of your transconductance graph which is plotted between your total current IC and your total input voltage VB, if I apply a small signal voltage here, so if this, as per your circuit explanation, your VB is very small, right? Input sinusoidal signal, if it is very small, it operates in the linear region. So if this small signal is given, it provides an equal variation in your collector current IC. So what is this capital IC? This is nothing but your Q point, right? IC and VB due to your DC bias condition. Now whenever I apply a small VBE here, there is a output in your collector current IC also. The output will be more. Okay, so this is what it is signifying. So now if your VB is very small, what will happen? It operates in the linear region. So this transition or this slope will give you the value of GM. So GM will be equal to, so what will be this GM? GM will be equal to slope, right? Rate of change of del IC divided by del VBE. So GM is equal to slope of IC VBE characteristic curve at IC is equal to capital IC, right? When small IC is the given value, capital a small IC is equal to capital IC, that is what at Q point. So GM will be equal to IC divided by VBE at your signal collector current will be equal to your DC collector current. That is, small signal approximation implies keeping the signal amplitude sufficiently small that the operation is restricted to an almost linear segment of IC VBE exponential curve. Okay, so this is just a graphical representation. Now moving on to the second derivation, you are going to find out the value of your base current. So what is your value? You have to find out I small b, right? Because it is small signal base current and input resistance. The input resistance is given as R pi, R suffix pi. Okay. So to determine the resistance seen by VBE, first evaluate the total base current. So you are going to first evaluate the total base current, small I capital B. So this is your total base current which you are going to evaluate. So what will be your IB? IB will be equal to, as per your current equation, what is your IB? IB is equal to total current IC divided by beta, right? Total current IC divided by beta. Now instead of IC, can you substitute the value? What is your total current, collector current IC? Your DC as well as your AC current, IC by VT into your VB, right? VB, which we have seen in the last derivation. Just substitute this here. So you will be getting IC divided by beta. Here you have a beta, right? IC divided by beta plus 1 by beta into IC by VT into VBE, which is equal to, what is your IC divided by beta will be equal to IB, capital IB, right? Capital, it is replaced by capital IB, and your 1 by beta into IC VT into VBE is replaced by small IB. Okay, so you can write it as your, so where IB is equal to IC by beta, and the small signal component IB is taken as the second term, because IB due to your signal component VBE. So the second term will be taken as your base current due to your small signal input voltage. So IB is equal to IC by beta into VT into small VBE. Let me take this as equation 13. Now you know that what is IC into VT, sorry, IC divided by VT, which is nothing but GM, right? So what will be your value? IB is equal to GM divided by beta into VBE. So this is going to be your equation of your base current. Okay, base signal current IB will be equal to GM into VBE divided by beta. Okay, so this is going to be your formula. Now you are going to, your next parameter is your input resistance. In order to find out the input resistance, the small signal input resistance between your base and the emitter, looking into the base is denoted by R pi, and it is defined as resistance is equal to voltage divided by current. What voltage? It is your AC voltage, right? Small signal. So small VBE divided by small IB. Okay, so you can substitute the value for IB now. Already you have found out. So what will be the value? R pi is equal to VBE divided by, what is your IB, GM divided by beta. So beta will come to the denominator, small VB. VB will get cancelled. So what will be your R pi? R pi will be equal to beta by GM. Okay, so this is your equation of your input resistance. Let me take this as equation 16. So R pi is directly proportional to beta and inversely proportional to your transconductance GM. Now you know what is the value for GM. Can you substitute it in this formula? So GM is equal to, what is the value for GM? GM is equal to IC divided by BT, right? So when you substitute here, you will be getting R pi is equal to beta divided by IC divided by VT. Just reconfigure it. VT divided by IC into beta. Now if I take this beta towards the denominator, what is IC by beta? You know that capital IB. Okay, you can reconfigure the equation as R pi is equal to VT divided by IB also. Okay, so these are the different possibilities which, so this can be remembered for your problems. Depending on which parameter value is given, you can solve the problem. So now you have found out your base current and your input resistance R pi. Base current will be equal to GM by beta into VBE, and R pi will be equal to beta by GM. Okay, now what is the next parameter you have to find out? The emitter current and the input resistance at the emitter. So what is your emitter current? Small I, small e, right? So the emitter current and the input resistance at the emitter. So what will be the total emitter current? IE. IE can be I. This will be your total emitter current, small I, capital E, will be equal to, you know, by means of the current equation, IC divided by alpha. Now what is your total current? IC. IC will be equal to your small IC will be equal to small I, capital C will be equal to DC plus your AC value. So here AC value I have directly written it as small I, small c. Okay, so this is your DC and this is your AC value. So IC by alpha plus small IC divided by alpha. This is small c. Okay, so your small I, capital E will be total emitter current will be equal to the combination sum of your DC plus AC, that is taken as your equation 18. Now where IE is equal to, you know that the DC emitter current is equal to collector current divided by alpha, right? By equation, what was your equation? Equation 2. So by means of equation 2, you are going to substitute the value. So that now this equation is IC by alpha, you know that it is capital IE, and a small IC by alpha is taken as your small IE, AC component. Okay, so I can write your small I capital total emitter current is equal to the combination of or sum of your DC and your AC, where what is your small IE? IE is equal to IC divided by alpha. Now you know what is the value for IC. IC by VT, right, into small VB. You are substituting the value. That is what written here. Small IE is equal to small I small c divided by alpha, which is equal to IC divided by alpha into Vt into small Vb. This is from equation 8 which you are getting. So you can write small I is equal to what is your IC divided by alpha. Again it is capital IE. So capital IE divided by Vt into Vb. That is taken as equation 19. Okay. So this is going to be your emitter current, small signal emitter current. Now what is the next you have to parameter? You have to find out the resistance. Small signal resistance between the base and the emitter looking into the emitter is given by Re. It is denoted as Re is equal to what will be the value? So R pi was equal to small Vbe divided by Ic, right? Similarly, what will be your Re? Re will be equal to only the current value will change, Vbe divided by Ie, small ie. So now you know that what is your from equation 19, you know what is IE, right? IE is equal to, substitute the value. So what will be your Re? Re will be equal to Vbe, Vbe will get cancelled, right? Re will be equal to Vt divided by IE. Okay. Now you are going to find out the relationship between your Re and R pi. So before that, if we compare equation 21 and equation 10. So what is your equation 10? You can write Re is equal to, instead of IE, you can substitute the value. IE is equal to capital IC divided by alpha. That is what written here. Okay. Re is equal to Vt divided by IC by alpha, which is equal to alpha into Vt by IC. What is your IC divided by Vt? You know that it is Gm. Okay. Now you are reconfiguring it in terms of Gm. So Re will be equal to alpha by Gm. So approximately you can take alpha is equal to IE equal to IC. So you can take the value as 1 by Gm. So Re is equal to 1 by Gm in terms of Gm. Okay. Now once you have found out Re and R pi, you are going to find out the relationship between your R pi and Re. Now what is your two equations which you have got? R pi is equal to, what will be the equation? Voltage VBE divided by IB. And what is your Re? Re is equal to voltage divided by current, right? IE. So if you cross multiply this, both this VB is same, right? VB is equal to R pi into IB. VB is equal to Re into IE. That is what written here. From equation 15, you have VB is equal to R pi into IB. And from equation 20, VB is equal to Re into IE. Both LHS is same. Left hand side is same. So you can equate these two. R pi into IB is equal to Re into IE. So you can write, you can take any one term. Okay. R pi is equal to, from this what will be your R pi IE divided by IB into Re, which can be written as beta plus 1 into Re. Or you can take from this Re, you can take, what is your Re? Re is equal to IB divided by IE into R pi, which is equal to R pi divided by beta plus 1. Okay, so these are your two relationship between your Re and R pi. And the last parameter is your voltage gain, right? So voltage gain, AC voltage gain AV will be equal to output divided by input. Output voltage is taken as VC and input voltage is taken as VBE. Okay, so we are going to find out AV is equal to VC divided by VBE. VCE can also be written as VCE. Okay. So the total collector voltage VC will be given as small v, capital C will be equal to VCC minus ICRC. So what is your IC in this case? Total collector current, which is a combination of both your DC as well as AC. That is what written here. Okay. So VCC minus IC plus small ic into RC. Now VCC minus ICRC minus small ICRC. You have expanded. Let me take this as equation 24. What is VCC minus capital ICRC? From equation you know that VC is equal to output voltage. VCE for DC condition, right? Which is equal to VCC minus ICRC. That is what this First two equation, VCC minus ICRC can be replaced by capital VC, which is nothing but the output voltage for DC bias condition, minus small ic into RC, where VC is your DC bias voltage at the collector and the signal voltage is given by. So what will be your signal voltage? IC into RC minus ICRC is taken as your signal voltage, that is your AC signal output voltage, small vc. Okay, small v small c, which is equal to minus IC into RC. But you know that GM is equal to, what is the value? GM is equal to IC divided by small VBE, right? So you can take IC is equal to GM into VBE. That is what it is substituted here. Instead of IC, you are substituting GM into VBE. So finally you can write VC as signal voltage, collector voltage VC is equal to minus GM into RC into VBE. So from this equation you have got in the right hand side VBE and in the left hand side VC. Now what is your voltage gain? VC divided by VBE, right? So if I take this, if I bring towards this side, I can write that AV is equal to VC divided by VBE, which is equal to minus GM into RC. When you substitute the value for GM, what is your GM in terms of your IC and your thermal voltage? GM is equal to IC divided by VT. If you substitute it here, I can write AV is equal to IC into RC divided by VT. So this is your expression for your voltage gain or small signal voltage gain. Okay. So if you make a table on the parameters which you have found out, this is all for AC signal, small signal, collector current, transconductance, base current, input resistance, emitter current, input resistance and voltage gain. So what is your collector current? Small IC will be equal to GM into small VBE, or GM you can replace GM by, now transconductance GM will be equal to capital IC divided by VT. So this two values is done. What will be your small base current, signal base current, small I small b is equal to GM by beta into VBE. And what will be your input resistance? R pi will be equal to beta divided by GM, right? What is your emitter current? Small IE will be equal to IE divided by VT into VBE. Okay, and what will be your input resistance? RE will be equal to 1 by GM in terms of GM. Okay, and finally your voltage gain AV will be equal to your VC divided by VBE, which is equal to minus GM into RC. Okay, so these are the different parameters which you have found out from the small signal operation and models of BJT. Okay, the notes will be available in my Telegram channel.